Hey guys, welcome to Unit 8A, Section 4, Circle Area and Sector Area. So this lesson is talking about a portion of the entire circle's area that we're looking at. So you could imagine it as though we just took a chunk, like a slice of pizza or something, and it's just a portion of the total area that is covered. The process is very similar to the same way that we found arc length. We're going to figure out the fraction that is covered by the area and then just multiply it by the total area. What's going to be different though is we're going to use the area formula for a circle, which is pi r squared. So pi times the radius squared. The formal definition of sector area is the region bounded by two radii of a circle and their intercepted arc. So we're going to look for the fraction, which is degrees out of 360, just like it was for arc length. And then the circle area, we use 2 pi r for the formula. So if you look at the first diagram, notice we have the gray shaded region, and the intercepted arc that we have for that is 106 degrees out of 360 in total. So we're going to multiply that by 2 pi, and then the radius is also given for us, which is 9. Oh, I'm using the wrong formula here. Back up. Pi r squared. So pi times 9 squared. If we were trying to find the arc length, that's what it would have been. So now what we do is we type this into our calculator. 106 divided by 360. Then we multiply that by pi, and then you can just go 9 squared like that. And we get approximately, we're going to round to 1 decimal place here. .9, and this is feet squared. Since we're talking about area, we have to square our measurements, our labels. All right, hopefully that process isn't too bad. The next one here, consider the shaded sector with the given area. Determine the area of the shaded sector. So again, look for your degree measurement. In this case, we have 80 degrees. So that's out of 360. So we're going to multiply that by pi r squared. So pi, and then it's going to be 2 squared. Now, if you know what the value of 2 squared is, which hopefully we do, we know that's just going to be 4. You can type that straight in your calculator too. So it's going to be 80 divided by 360 times, this would end up being 4 pi, or 4 times pi. And we get approximately, if we round to 1 decimal place, 2.8 feet squared. Also, think about 2. Does this seem like a reasonable answer? If we look at our radius, that's 2. 80 out of 360 is definitely going to make it a smaller portion of the entire circle, so I would agree that that's pretty accurate. And then the last one, this is kind of the type of problem where you have to work backwards. Consider the shaded sector with the given arc length. We don't see the shaded sector, but it's talking about this part over here. So determine the radius. Looking at this, we see that we have the arc length. That's what the value is on the outside. So we need to work backwards using the idea from the previous lesson with arc length. So to do this, remember that it is the arc length, 19.71, equals our fraction of 55 out of 360 times 2 pi and then the radius, which is what we're trying to figure out. So this is the old formula from arc length because we don't know the sector area. So what we need to do is we can simplify a lot of what this is. We can just multiply some pieces together. So we're going to get 19.71 equals, and then we can just multiply this with the top, which would be 110 pi over 360. And we can leave the r on the side because that's what we're solving for. So what I'm going to do is I'm going to figure out what this decimal is here. This 110 pi divided by 360, and we get 0.9599. So I'm just going to round that to 0.96. So it's 19.71 equals 0.96 times the radius. We're going to divide by that to this 19.71. Divided by 0.96, we get approximately 20.58 is what we'll round that to. So R is about 20.58 centimeters. Now it wants us to determine the area of the sector using the minor angle. So now we're going to use the normal formula. Thinking about the degrees, it would be 55 out of 360 times pi r squared, and r squared in this instance is that 20.58. So I'm going to type this into my calculator. A lot of calculator work for these two lessons. And we get 202.9. And that would be, our label is in centimeters, so centimeters squared. Okay.